Hi, in the last video, we have discussed about the exponential function, natural exponential function, and we have studied that is the inverse of the natural logarithm, and so many properties we have understood, and with using that properties we have to do some problems, right? So solve e raised to 2 minus 3x is equal to 6, and the second question is log 2x plus 5 equal to 4. You have to solve means you have to find the value of x here, right? So look at the first question. Solve e raised to 2 minus 3x is equal to 6. So in order to solve that, taking logarithm on both sides, so log e raised to 2 minus 3x is equal to log 6, right? So the natural log, we know that the natural log x raised to r is equal to r natural log x, right? So from this we can say that this is 2 minus 3x into log e, which is equal to log 6, and we know this log e is equal to 1. So 2 minus 3x is equal to log 6. So what implies 3x is equal to 2 minus log 6, right? So x is equal to 2 by 3 minus log 6 divided by 3, right? The answer is given by, approximately you do it in using the calculator, 0.0694, right? Look at the second question. This log, the question is log 2x plus 5 equal to 4. In order to obtain the solution, that is, we have to find out this x. So we have to eliminate this natural log. The only possibility is take the properties of the natural log and the natural exponential. So taking exponential on both sides. Taking exponential on both sides. On both sides we get e raised to ln 2x plus 5 is equal to 4, which implies by the properties of the exponential and the natural log 2x plus 5 is equal to e raised to 4, which implies 2x is equal to e raised to 4 minus 5, which implies x is equal to 1 by 2 into e raised to 4 minus 5, right? So approximately the answer will be the 24.80, right? So move on to the next problem using the properties of the natural exponential function. Next question is I'm going to do is find limit t tends to infinity e raised to 2t plus 1 divided by e raised to 2t minus 1, right? We have a t tends to infinity. At the first look we can say that as t tends to infinity, e raised to 2 infinity plus 1, this is e raised to 2 infinity minus 1, right? So e raised to, this will become e raised to infinity, that is at the first center this e raised to infinity plus 1 by e raised to infinity minus 1. So we cannot move on to the next stage, right? So I'm writing this as here, I'm taking e raised to 2t plus 1 divided by, plus 1 e raised to 2t minus 1. I'm writing this as I'm taking the e raised to 2t outside, 1 plus 1 by e raised to 2t. Here also I am taking e raised to 2t outside, 1 plus 1 minus 1 by e raised to 2t. Right? So I have taken e raised to 2t on both sides. So e raised to 2t into 1 plus e raised to minus 2t divided by e raised to 2t into 1 minus e raised to minus 2t. E raised to 2t getting cancelled, and which implies 1 plus e raised to minus 2t divided by 1 minus e raised to minus 2t. So the function is changed into this way, right? So we can apply the limit in this function. So limit t tends to infinity 1 plus e raised to minus 2t divided by 1 minus e raised to minus 2t, which is equal to 1 plus e raised to minus infinity divided by 1 minus e raised to minus infinity, which is equal to, we know that e raised to infinity equal to infinity and e raised to minus infinity equal to 0. Right? So using this assumption, this is 1 plus 0 divided by 1 minus 0, which is equal to 1. This is the answer. Right? And also next we have to look at the integration and differentiation of the log x, right? So we have to study that integration and differentiation of log x. We can this is the properties. The properties are log e raised to x is equal to x belongs to minus infinity, infinity. E raised to log x equal to x, for x belongs to 0, infinity. Right? So, and the properties of this is equal to, the domain is minus infinity, infinity, range is 0, infinity, which is increasing and continuous on this interval, concave upward on this interval, a limit extending to minus infinity e raised to x is equal to 0. That means e raised to minus infinity equal to 0 and e raised to infinity equal to infinity. Right? And you know the result of exponential, e raised to x into e raised to y equal to e raised to x plus y, e raised to x divided by e raised to y equal to e raised to x minus y. Right? So next is the derivative of the exponential. D by dx e raised to x is equal to e raised to x itself, and d by dx of e raised to u is equal to e raised to u into du by dx, where u is x, where u is a function of x. The proof of the first one, let y equal to e raised to x, taking logarithm on both sides. Log y is equal to x, derivative on both sides, 1 by y dy by dx equal to 1, dy by dx equal to y, which is equal to e raised to x.